Hi everyone and welcome back. So today we're going to be wrapping up our discussion of ellipses. So this is day 2. So we already talked about this, but you guys can write down in your own words really what is an ellipse. So however you best understand how we create this shape with our two foci. Remember we talked about how we can start out as a circle, and then if I stretch the endpoints, it will turn into an ellipse where we have our two foci, whereas there used to be just a center for a circle, but now I have not only the center, but also my two foci on either side. All right? So I'll write down the formal definition for us, but again, it's however you choose to interpret it. All right, so to provide you with a more formal definition here, we have an ellipse for two given points, the focus or the foci. The ellipse is the locus of points such that, that's what the S dot T means, such that the sum of the distance to each focus is constant. Okay, so now let's just continue. So that's just our basic definition. So given the following equation for an ellipse, what is the center? So remember, the center, think about it similar to the equation of a circle in center radius form, very similar. Except now we have our major and minor axes taking a role. But the center is just going to be at 2, -3. Remember, we take the opposite signs of what's inside the parentheses. And I ask for the length of the minor axis. So the minor axis is going to be the smallest value. So there's our smaller value. And that is b squared. So I have b squared equals 16, which means b is equal to 4. And the minor axis is always twice the b value. So I have 2 times 4, which is 8. So there's my minor axis value. Okay, just a little bit of a recap. You guys do need to know these two different equations. Here is the standard equation for an ellipse, whether it's smushed flat like a pancake or if it's elongated and stretched vertically. Right, we talked about the two differences. So this example would be describing a compressed circle turning into an ellipse. And then here we will be talking about an elongated circle that is stretched vertically. Okay, so for our first exercise, again, this should all be really review for us today. We want to find the center and lengths of the major and minor axes for the given equation. Now remember, to get this in the ellipse form for the equation, we have to get this equal to 1. So we're going to divide everything here by 36. So I'm looking at 9 over 36 x squared plus 4y squared over 36 equals 1. 9 over 36 we have is 1/4. So I have x squared over 4 plus y squared over 9 equals 1. We know that, again, the larger number is going to be our a squared, so then that means this is our b squared. So we know that this ellipse is going to appear vertically elongated, right? So that's going to be the shape. So let's actually start to sketch this out. We know that it's centered at 0, 0 because of the change in x and the change in y having 0 in between. So this is my center at 0, 0. And we know, so let's actually write this out. We know our b value is going to equal 2. Our a value is going to equal 3. So we want to know the major and minor axis. Remember, you double both of those values. So the minor axis is going to be 2 times 2, which is 4. And then the major axis will be 2 times that 3, which is 6. And we know that this is being stretched vertically. So I'm going to travel 3 units up, 3 units down, 2 units left, 2 units right. So those are my vertices at 0, 3, and then 0, -3. So make that sketch as best you can. And we can write that in as 0, 3, and then 0, -3. And guys, that's it. We did it. We found the center, the lengths of the major and the minor axes, and we sketched it. So we're all set to go. We're good. Okay, let's keep going. So again, we're still focusing on ellipses here. We're going to add in some new definitions as well. What would be a math lesson without anything being new taught? Okay, so question 2 here. This is actually just additional practice, so I'm going to skip over this, but I'll post the solution for those of you that want that extra practice. All right, so again, I'm not going to go over this. I went over plenty of these questions in our other lesson, and I just went over one similarly above. So if you want to pause the video here, I'm going to post the solution now. All right, so this is what my graph would look like. We have our vertices here at 0, 5, and then 0, -5. And these points over here would be 1, 0, and then negative 1, 0. We also know that because our a value is 5, that means the major axis is going to be 10. Remember, we double that number. And then the minor axis, we know double 1 would be 2. So my minor axis would be 2. And we answered all the questions. We have a nice sketch here. It's centered at 0, 0, and this looks good. Okay, so now I'm going to start to introduce some new terminology here. So we need to talk about eccentricity. If you guys have ever heard of about eccentricity in terms of like the orbit or the Earth around the sun, or the other planets such as, Mars, Jupiter, etc., they all have different eccentricities. So that oval-like shape that they make going around the sun, right? So you can have an ellipse maybe that's stretched longer, maybe it isn't stretched out as much, or maybe it's super stretched out, okay? And the eccentricity value, the way that we find how eccentric, so whether this is shaped out really long or if it's really not stretched out that much, so maybe it looks more like a circle, but it still has that oval-like shape, because a perfect circle means there has to be an equal radius distance all the way around. So maybe you have something that's slightly longer horizontally and then a little bit shorter vertically, right? So maybe it might look like a circle, but it's not. Again, that's where eccentricity comes in. So the formula that we're going to be using for eccentricity is E equals C over A, where C is the distance from the center to the focus of the ellipse. So that's something we already talked about. And then A, remember 2A is the major axis. So if we want just A is the length of the semi-major axis, because we're taking half, right? Think of like if I said a circle and I wanted a semicircle. So if you have a full circle, a semicircle is just half. So you cut it in half. So if I want, here's the major axis, but I want the semi-major axis, I'm only looking at half. So that would be my A value. Okay, so now that we have that terminology locked in, let's take a look at some practice problems that includes eccentricity. And I give you guys just a little visual here of the different kinds of eccentricity. So the eccentricity for a parabola is equal to 1. The eccentricity of a hyperbola, which is what we're going to be getting to in our next lesson, is 2. The eccentricity for the directress is infinity, because it's just that vertical line. And here's an example of an eccentricity of an ellipse that's at 0.5. The eccentricity actually of an ellipse can vary from 0 to 1. If it equals 1, it becomes a parabola. But if I want just the eccentricity of an ellipse, it's between 0 and 1. All right, so these are actually some pretty important facts I want you to make sure you have written down. So make sure you have that written, okay? All right, so let's look at question 3. Question 3 says, find the eccentricity of the ellipses from exercises 1 and 2. So from exercises 1 and 2, well, let's go back. For exercise 1, we found, and I'm just looking at my paper here, we found our A value to be 3, and our B value was 2. So this is for the first example. So let's write out, and remember, eccentricity is C over A, and the formula for C is the square root of A squared minus B squared. So we'll have C equals the square root of 9 minus 4, so C is the square root of 5. And eccentricity is C over A, so for this first example, we'll have the eccentricity is equal to square root of 5 all over 3. Now, I'm actually going to put that in my calculator, because if that number is greater than 1, I did something wrong. Because remember, eccentricity of an ellipse has to be between 0 and 1. So type that in the calculator and see what decimal value you get. All right, so when I typed this in the calculator, I got that this value is approximately 0.745 with additional decimal values. So 0.745 is smaller than 1, so this checks out. We did this right. So we know that this is going to be an ellipse. Okay, let's take a look at the second example, which I already did for you guys up here. So we know that our A value, I had that written already, our A value was 5 and our B value was 1. And we can find our C value. Remember, it's the square root of A squared minus B squared. So let's write that out. we'll have c is equal to the square root of 25 minus 1. So c is equal to the square root of 24. Remember, eccentricity is c over a. So we'll have e equals square root of 24 all over 5. And again, I'm going to type that in the calculator. I want to make sure that number is between 0 and 1. If it's bigger than 1, we did something wrong. So type it in the calculator, see what you get. All right, so when I type this in my calculator, I got the eccentricity for this value to be 0.97979589 ... right? So that number is between, again, that's 0 and 1, so we know it's an ellipse. If we reached the eccentricity of 1, remember that would have become a parabola. And again, like I said, we're going to get into more of this stuff coming next week, where we're going to talk about hyperbolas, all of that fun stuff. I think you guys are actually really going to like that. Alrighty, now let's take a look at some more ellipse practice. So again, this is more practice with completing the square. So let's take a look at that. Okay, so for our equation here, we're going to write this out more conducive to completing the square form. So I'm going to write this out as 4x squared, move that over, minus 8x plus blank plus 9y squared plus 126y plus blank is going to equal, I'm going to move this negative 131 to the other side. So 131 plus blank plus blank. Okay. Next thing we're going to do is I'm going to take a look at these three terms. Remember, it's going to turn a trinomial into a binomial squared. So we're going to factor out the 4 as x squared minus 2x plus blank, plus factor out the 9 for these three terms as y squared plus 126 divided by 9 is 14y plus blank is going to equal this 131 plus. Now remember, the 4 is factored out here, and the 9 is factored out here. So that needs to be included outside of our boxes. So I have plus 4 outside of my box. That's going to get multiplied plus 9 times what's outside of the box here. So now we can start to complete the square. Remember, that needs to be included on both sides, these values. Because I factored out a 4 and I factored out a 9, it's got to take place on both sides. All right. Now I have 4 times, complete the square here, half of 2 is x minus 1 squared. We're adding 1 to both sides, remembering that this is going to end up getting multiplied. Plus 9 times, I have y plus 7 squared, because half of 14 is 7, and 7 squared is 49, so I'm adding 49 on both sides. Again, these are going to get multiplied. Combine like terms here. 131 plus 4 plus 9 times 49 is 576. And we want to get this into standard form for an ellipse. So remember, everything has to be equal to 1 on the right-hand side. So I'm going to divide everything out by 576. And we're going to simplify. So I'll have x minus 1 squared over 144. Plus y plus 7 squared all over 64 is equal to 1. So now this is in the correct form. This is in the form for an ellipse. This is in standard form. So now we want to actually sketch this out. So I'm going to erase what I have. So make sure you guys have this written. I'm going to erase what I have. That way we can come up with a sketch, come up with the major and minor axes, and we'll be done with this question. So pause the video here. Make sure you have this all written. I'm about to erase it. Okay, so here's my equation. Now, I do want to come up with what the major and minor axes is. So here, remember, that's going to be our a squared. The bigger number is a squared. The smaller number is our b squared. So I'll have a equals 12 and b equals 8, because 12 squared is 144. 8 squared is 64. That means that 2a is going to equal 24, which is our major axis. And then my minor axis is going to be 2b, which is 16. So our minor axis has a value of 16. We know that this is centered. So the center is at 1, -7. And again, we have our a value is 12. Our b value is 8. So I'm going to make a sketch. Okay, so that's my rough sketch of my ellipse here. We have it centered at 1, -7. We know the minor axis is 16, so this entire length from here to here is 16. We know the major axis has a total length of 24. Again, it's just a sketch. And we are done. Let's move on. All right, so let's take a look at the next question. I want to take a look at question 2. A little bit more critical thinking here. So let's erase this. So question 2. We want to find in standard form the equation of an ellipse that have two foci at 0, 1 and 4, 1. And then the major axis is a length of 6. So I'm going to draw out a little sketch here. I have a point at 0, 1. And then I have a point at 1, 2, 3, 4, 1. So as best as I can. So that's the point 4, 1. That's foci 2. And then this will be foci 1. And that's 0, 1. And we want to figure out where this is centered. So if these are my two foci, is at 0, 1 and 4, 1, well, I can easily just use the midpoint formula, or I can look at this visually and tell that this has a total distance of 4, meaning my center is going to be 2 units away and 2 units away from each of one of the foci. So my center will be right here at 2, 1. So I can already start to write my equation. I have x minus 2 quantity squared plus y minus 1 quantity squared. The whole thing has to equal 1. And now we got to figure out our a and b values. Now I already know that the length of the major axis is 6, so I know 2a equals 6. So when I divide that out by 2, remember the major axis is twice the a value. So if I have 2a equals 6, I know a equals 3. So if a equals 3, now we can use our formula of c equals the square root of a squared minus b squared. And remember, we actually already know what the c value is because it's the distance from the center to one of the foci. So center to one of the foci, which we already said that distance is 2. So I have 2 will equal the square root of 3 squared is 9. So I have 9 minus b squared. I'll square both sides. So I'll have 4 equals 9 minus b squared. Let's switch things over, bring that over, and bring that over. I'll have b squared equals 5, so b is equal to the square root of 5. So now I know the length of the semi-major axis is square root of 5. So we know then that b squared will equal 5, and we know a squared is equal to 9. So now we're just going to fill in on our equation. We'll have x minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. And guys, that's it. We are done with this question. Finished. That's everything. All right. Okay. Let's take a look at question 3. So we're going to identify the length of the major and minor axis as well as the eccentricity. All right. So I'm going to erase what I have going on here and let's do this question together. All right, so immediately I can tell already that I'm going to need to complete the square. So let me just clean this up and write this out. I'll have 2x squared. I'm bringing that over. I'm going to bring the 8x over. So plus 8x plus blank plus, bring this y squared over, y squared minus 16y plus blank equals, bring over the 52, negative 52 plus blank plus blank. All right, going to take out the GCF here, so I'll have 2 times x squared plus 4x plus blank. Take out the GCF here, which actually, it's just 1. So I'm going to rewrite this as plus 1 times y squared minus 16y plus blank equals the negative 52 plus. Now, I pulled out a 2 here, so I need to write plus 2 times what's in the box plus. All I took out, guys, here was a 1, so you really don't even need to write this, but just to keep things consistent. So I'll write plus 1 times what's in the box. Okay, let's start to complete the square here. So let's do this. We're going to change this from a trinomial to a binomial squared. I have 2 times x plus 2 quantity squared. That will be plus 4 here and plus 4 here. I have plus, we have this trinomial will become a binomial squared of y minus 8 squared plus 64 plus 64. Again, you don't really need that 1 out there, but if you want to keep things consistent, go ahead. All right, now I'm going to combine like terms, and on the right-hand side, negative 52 plus 2 times 4 plus 64 ends up resulting in 20. I'm now going to divide everything out by 20 because we want this to be an ellipse. Remember the eccentricity, we got the major and minor axes. So divide everything out by 20. And I'll have my equation to be x plus 2 quantity squared all over 10 plus y minus 8 quantity squared all over 20 is equal to 1. So that's my equation for the ellipse. Now we want to come up with the major axis and the minor axis. So we can already tell, remember the bigger value is our a squared. So here's our a squared, here's my b squared. So I have a squared equals 20, and I have b squared equals 10. So if I square root both sides, I know a is equal to square root of 20. If I square root both sides here, I know b is equal to the square root of 10. And remember, the major axis is twice a. So 2a is going to equal 2, red, 20. All right, clean that up a little bit. So 2a equals 2 times the square root of 20. So that's the major axis. And then the minor axis is twice the square root of 10. So 2b will equal 2 times red, 10. So this right here is my minor axis. So we can check that off. We entered the minor axis, we entered the major axis, and now we want to come up with the eccentricity. So now remember, eccentricity, E equals C over A. Well, we can find C very easily. We have C is going to equal the square root of a squared minus b squared. So we'll have C equals the square root of a squared is 20, b squared is 10. So we'll have C equals the square root of 10. If C equals the square root of 10, we're just going to plug that in right up here. So let's do it. We'll have, I'm running out of space, let's write this over here. E equals square root of 10 all over. Now A, where is A? A is right here, square root of 20. So I have square root of 10 over square root of 20, which can simplify to the square root of 1/2. Okay, and the square root of 1/2, well, let's rewrite this. This is really the square root of 1 over the square root of 2, which is really just 1 over rad 2. And hey, we can rationalize, get rid of that radical. So this is really just rad 2 over 2, which hopefully, if you remember from our trigonometry unit, that's actually one of our values for one of the special reference angles that we use. So if I asked you for the sine of 45 degrees, you would say rad 2 over 2. If I asked you for the sine or cosine of 45 degrees, you would also say rad 2 over 2. So that's actually just a special fraction. So anyways, so we've actually concluded this problem. The eccentricity is radical 2 over 2. And now again, because we're dealing with an ellipse, the eccentricity value has to be between 0 and 1. So I actually already know radical 2 over 2 is something like 0.7071006 blah blah blah. So because that falls within our interval from 0 to 1, we definitely did this correct, and we know that we're looking at an ellipse. All right, guys, last problem of the day. We are going to take a look at this application of an ellipse. This is actually a really, really cool problem. I'm excited to show you it. All right, so we have a train track runs through a tunnel through a mountain in the form of half of an ellipse. So this is half of an ellipse right here. Okay. We have the tunnel is 20 feet high. So here is my half of the ellipse. Let's draw that in. Half of the ellipse. And we're at 20 feet high. And from the center, which we know, okay. And it's 16 feet wide, so we know from here to here is 16. Assuming the train is 10 feet wide, so our train is going to fall within here, somewhere at 10 feet wide. What is the height of the tallest train that can pass under the overpass? All right, so I'm actually going to create a bigger sketch here. So let's see, here's our ellipse, half of the ellipse. We have the height from here to here, from the center, is 20. We know the distance from here to here is 16. And we know that the train is 10 feet wide, so that's here. And we want to see what's going to be the height that this thing can reach before it would accidentally hit the top. So we're actually going to figure out what that height is. And we're going to assume that this is centered at 0, 0. So let's assume that this is centered here at the origin. Make our lives easier. Centered at 0, 0. So my center is at 0, 0. And now we know that the height is 20 feet high. So guys, this is very obvious for us that we should know that the 20 is representative of the semi-major axis. So 20 is equal to the semi-major axis. And then the 16 represents the entire minor axis. So 16 represents the entire minor axis, right? Because if I really wanted to elongate and create the final ellipse, we would still have an additional 20 here. But I don't want that 20, right? We're just looking at half of this ellipse anyway. But regardless, this is still going to have a length of 16. So the minor axis has a length of 16. And then if you really want to think about the major axis in total, the major axis in total will have a length of 40, but we don't really care about that. So I'm not going to include that value. All right, so let's erase that. Okay, so if we know the semi-major axis has a length of 20, well, then we know A equals 20. And the minor axis, so that's a length of 2b. The minor axis is 2b, so I'll have 2b equals 16, so b equals 8. Okay, now we can start writing our equation for the ellipse. So I'm going to write this already. We know it's centered at 0, 0, so I'll have x squared plus y squared all over. Now, if you remember what we just kind of sketched out before, I'll kind of reiterate that here. You can tell that this ellipse is longer vertically. So we know our a squared value will pair with a y squared because this is longer vertically than it is horizontally. So we'll have our a squared value here and our b squared value with x. This all equals 1. So I'll have x squared plus y squared, b squared, so b is 8, 8 squared is 64, plus y squared all over a squared, and a is 20, and 20 squared is 400 equals 1. So this is our equation for the ellipse. Now the question is asking, well, let's go back and read. So now that we have the equation for the ellipse, and that's great, this is probably one of the harder steps, now we just need to go back and read. Well, if we know that the train is 10 feet wide, so if the train is 10 feet wide, well, we know from here to here, that's a distance of 5, and here to here, that's a distance of 5. So we know that when x is 5, remember this is centered at 0, 0 here, so I'm moving 5 units to the right, so that's at 5, 0 right here, but I want to know what the height will be. So when x is 5, we want to travel all the way up to figure out, well, when x is 5, what's this y value? So we have to use our equation for the ellipse here to figure out what's this height for the y value. We know x is going to equal 5. I could have also used -5 if I wanted to here, right? Because we moved 5 units also to the left. But I'm just going to keep with the positive values. It doesn't matter. So let's plug in. If I know x is equal to 5, we're trying to find that y value. So I'll have 5 squared all over 64 plus y squared over 400 equals 1. I'm going to simplify a little bit here. I'll bring over the 25 over 64, 25 over 64. I can rewrite 1 as 64 over 64. So I have y squared over 400 equals 64 minus 25 is 39 all over 64. Now I'm going to cross multiply. And I'll have 64y squared is going to equal 400 times 39 is 15,600. Divide by 64 on both sides. And now I have y squared equals, we have 243.75, square root both sides. And I'll have y equals 15.61 feet. All right? So there you guys have it. The maximum height that this train could be. So what's the tallest height? The max height it could be would be 15.61 feet. Otherwise, it's not going to clear the opening of the tunnel, right? If it's any taller than that 15.61 feet, it's going to end up crashing. All right, guys, I hope you found this video helpful. This concludes our lesson on ellipses. Get ready for hyperbolas. Those are up next. All right, guys, I'll talk to you soon. Hope you guys have an amazing day and keep in touch. Bye-bye.